Good morning, students. Yes, last lecture we have discussed some questions. Now it's time for some extra equations, which is not given in textbook, but yes, you have to remember to solve MCQs. Okay. See, we know that due to long wire, means we can say we're having infinite length, Yes, it is wire having infinite length. What is equation of magnetic field? Outside, for example, at distance r. Yes, we know that equation of magnetic field is equal to mu 0 I upon 2 pi r. B is equal to mu 0 I upon 2 pi r. Clear about this? Okay. But if you are given wire of finite length, then what is magnetic field and how to find that magnetic field? See here, if it is wire having finite length, current flowing is I. Okay, I want to find magnetic field at this point. Okay, then how to find? First of all, it is one current carrying wire having finite length. At this point, we want to find magnetic field. From this point, draw one normal on wire. Clear about this? From this point, draw one normal. Means it makes angle 90 degree with this one. Okay? Clear about this? This distance is called y. Perpendicular distance is called y. Now, connect this point with one end and name it theta 1. Connect another end with this point and name this angle as theta. Clear about this? What is figure? It is one straight wire having current I. At this point, at point P, you have to find magnetic field. Connect this point, draw perpendicular with y. Connect these 2 points with 2 ends. So see, these 2 ends make some angle with this perpendicular, theta 1 and theta 2. Then what is equation of magnetic field at point P? Magnetic field at this point is given by B is equal to mu 0 I upon 4 pi y. B is equal to mu 0 I upon 4 pi y sin theta 1 plus sin theta. This equation you have to remember. Yes. This equation is given in textbook. We have proved with the help of Ampere's circuital law. This equation you have to remember. Okay, if wire is of finite length, then equation of magnetic field B is mu 0 I upon 4 pi y sin theta 1 plus sin theta 2, where y is perpendicular distance, theta 1 and theta 2 angle made by that point. Clear about this? Okay. Now, in this equation, we will take some cases. For example, if you are given finite wire like this, current flowing is I, and if we want to find magnetic field at one point on its end, we want to find magnetic field at this point. We want to find magnetic field at this point. Clear about this? Then how to find it? Yes, we have to follow our method. Draw perpendicular. This distance is y. Okay, connect to first end. Okay, so yes, this angle is theta 1. Connect second end with this point. What is theta 2? 0. What is theta 2 here? It is 0. Clear about this? Again, we want to find magnetic field at this point. So yes, draw perpendicular. See again I'm repeating method. Okay, we have to find here at one end. Draw perpendicular, it is y. Okay, now connect two ends. First end connected, because it becomes angle theta 1. Second end, if you connect this point, so it is same line, so theta 2 is equal to 0. Putting above equation, then you will get B is equal to mu 0 I upon 4 pi y. Mu 0 I upon 4 pi y. Sin theta 1 plus sin theta 2, it is 0, and sin 0 means it is 0. Yes, so B is equal to, it is mu 0 I upon 4 pi y. Clear about this? Okay, so yes, if you have to find, okay, magnetic field at any end of this wire, then you will get V is equal to mu 0 upon 4 pi. Okay, if you are given wire of infinite length, this one, okay, then how to find magnetic field means we will obtain this equation by second method. Okay, let this one point that we have to find magnetic field. Draw perpendicular to this one. Now see, this wire is of infinite length. Means this length is very large comparatively to this. Means this length is negligible. So if I connect this end with this point, I connect this point with this end, these two lines will be almost parallel. Yes or no? See, this distance is very large. Then see this angle. It is nearly 90. So yes, for wire of infinite length, theta 1 is equal to theta 2 is equal to 90. Put in this equation. Then B is equal to, it is mu 0 I upon 4 pi y sine 90 plus sine 90. We know what is value of sine 90? 1 plus 1, 2 divided by 4, it is 1 by 2. So yes, B is equal to, it is mu 0 I upon 2 by y. This equation. Clear about this? So yes, you have to remember these equations. Okay, yes, again, it is not given in textbook, but in competitive exams, JEE, NEET, Gujarat, okay, there is use of this equation. B is equal to mu 0 I upon 4 pi y sin theta 1 plus sin theta 2. Also, in chapter number 6, we will have 1 or 2 sums based on this equation. Okay, so yes, you have to remember these extra equations. Another one extra equation. See, here it is. We know that if we have a circular coil having n turns, then magnetic field at center, B is equal to mu 0 Ni upon 2. Okay, if I have only one turn, circular coil having one turn, then I have to take n is equal to 1. Simple. Then what is magnetic field? B is equal to mu 0 I upon 2r. Simple? Yes, it is simple. Yes. This equation we have proved. Circular coil, radius capital R, having n turns, magnetic field at center is equal to mu 0 Ni upon 2r. Circular coil having one turn, n is equal to 1, B is equal to mu 0 upon 2 pi. Okay, now if I have one arc, it is center, it makes angle theta, it is radius, and it is current flowing from it I. See, for n turns it is equation, for one turn it is square equation, then for angle theta, what is equation of magnetic field? Yes, current carrying conductor produces magnetic field. Then what is magnetic field at center? See, we will use this equation. B is equal to mu 0 Ni upon 2r. Here it is. B is equal to mu 0 Ni upon 2r. But we have to put n value of n. N means numbers of turns. If we have circular coil having one turn means like this. Then it is called n is equal to 1. One turn means angle 2 pi. One turn means angle 2 pi. Yes or no? Yes, it is. So yes, if you have angle 2 pi, then numbers of turns is equal to 1. Here is arc substance angle theta, that for angle theta, number of turns, then yes, n is equal to, it is theta upon 2 pi. N is equal to, it is theta upon 2 pi. So d is equal to mu 0, it is theta upon 2 pi, I upon 2 pi. So you will get d is equal to mu 0 I theta upon 4 pi I. It is equation that you have to remember. It is equation that you have to remember. Whenever you are given arc like this, current I, radius R, substance angle theta at center, then what is magnetic field at center? It is magnetic field at center. So yes, it is again one extra equation that you have to remember. For n turns, for 1 turn, for this arc. If you are given semicircular arc, if you are given semicircular arc of radius r, then what is magnetic field at center? What you have to do, see, semicircular arc means, it makes angle. What is angle of semicircular arc? It is pi, 180 degrees. Simple. This theta you have to replace. This theta you have to replace by pi. If you replace this theta by pi, you will get your answer. You will get your answer. Also, for whole circle, theta is equal to 2 pi. Put here theta is equal to 2 pi. You will get this equation. T is equal to mu 0 I upon 2 pi. Clear about this? So yes, this equation you have to remember, because now we will see some questions based on this equation. Some questions based on this equation. Okay? Next question is example 4.6. Current I is equal to 12 ampere is flowing from this wire as shown in figure. You have to find what is magnetic field at this point inside the center. Okay? Now see, we can divide this whole object in 3 segments. First, this wire A, see this one, it is 2 and it is 3. Clear about this? Then at this point magnetic field is due to this straight segment 1, this semicircular arc 2, and this straight segment 3. Okay. Now for wire, yes, this of infinite length like this. And yes, see, if we have wire like this, see, if it is wire, current flowing is I. Okay. If I want to find magnetic field at this point, that is on its axis at this point, what you have to do? Yes, you have to draw position vector in that direction. So yes, it is direction of position vector. What is equation of magnetic field? B is equal to Bio-Savart's law. B is equal to mu 0 upon 4 pi I dl cross R. I dl cross R. Here, I dl and R, they are in same direction. Or if you know equation, what is equation? B is equal to mu 0 upon 4 pi I dl sin theta upon R square. If I and R, they are in same direction, then angle theta will be 0. Angle theta will be 0. So yes, magnetic field is 0. So yes, you have to remember, if a point lies on axis, then magnetic field is 0. Okay, like this, if it is wire, current is flowing, then on axis, at each and every point, at this point magnetic field is 0. At this point also, for this point angle becomes 180, then it is 0. Then on axis of wire, magnetic field B is equal to 0. Clear about this? This point you have to remember. Now, for this case, question number 8. See, here it is. This straight wire. This point lies on axis of this first wire. Then B1, due to that magnetic field is 0. Yes or no? Similarly, current is flowing in this direction. This point is on an axis. Then B3 is equal to 0. Yes or no? here magnetic field is due to only this circular part. Then yes, P2, here it is. How to find? Yes, we have obtained one equation. Mu 0 I theta upon 4 pi r is equal to mu 0 I semicircular arc, means angle is pi, so yes it is pi, upon 4 pi r, pi cut means it is mu 0 I upon 4 r. What is equation for whole circle? Mu 0 I upon 2 r. For half it is this. Clear? Yes. What is direction? What is direction? See how to find direction of magnetic field. Right hand. Wrap your fingers in direction of current. Again, right hand. Wrap your fingers in direction of current. Wrap your fingers in direction of current. Thumb indicates direction of magnetic field. See, this thumb is perpendicular to page going inside. So here magnetic field is going inside, means cross. Yes, you know it is B, resultant magnetic field. B is equal to B1 plus B2 plus B3 is equal to mu 0 I upon 4r, perpendicular to power going inside. Okay. Now for question number B, whole arrangement is same, just this is inverted. So again, what happens? 1, 2, 3. Due to B1, here it is 0. Due to B3, here it is 0. Due to B2, magnitude will be same, that is mu 0 I upon 4r. But what about direction? Current is going in this direction. So wrap your fingers in direction of current. Wrap your fingers in direction of current. Thumb is perpendicular outside. So yes, here resultant magnetic field B is equal to B1 plus B2 plus B3 is equal to mu 0 I upon 4r. Outside, like this. Perpendicular outside. Perpendicular outside. Clear about this? So yes, it is one question based on this equation. Okay. Now next question, example 4.7. A circular coil having turns N is equal to 100. Radius R is equal to 10 cm. Current flowing from this is I is equal to N ampere. What is magnetic field at center? Yes, it is simple question. You have to use this equation. B is equal to mu 0 Ni upon 2r. P is equal to mu 0 Ni upon 2r. Mu 0, 4 pi into 10 raised to minus 7. Yes, you have to remember value of mu 0. It is 4 pi into 10 raised to minus 7. Okay, so yes, you can easily calculate. Okay, next one is exercise 4.3. Current I is equal to 50 ampere is flowing in south direction. What is magnetic field at 2.5 meter east? What is magnetic field at 2.5 meter east? See, first of all, we will find magnitude because it is easy to find. Okay, see, here it is. Current, it is flowing in south. It is north, it is south. I is equal to, here it is 50. You have to find magnetic field in east direction. At distance to R is equal to 2.5 meters. So yes, you have to use this equation. P is equal to mu 0 I upon 2 pi r. P is equal to mu 0 I upon 2 pi r. Mu 0 4 pi into 10 raised to minus 7, I 50, 2 pi, that is 2 pi, and R is 2.5. Now what is important? Direction. Direction. See, you have to find magnetic field at this point. So it is R. See, what is simple now? Current is going in this direction, ideal cross R means in this direction and in this direction. Now see, understand, here it is north, south, east, here it is west. Yes or no? North, south, east, and here it is west. Current is going in this direction, position vector in this direction, it is in this direction. This direction means upwards. This direction means upwards. See, east, west, north, south, upward direction and downward direction. Yes or no? So yes, ideal cross R. This direction means upward, vertically upward. So yes, it is in upward direction. Clear about this? So yes, it is again one question that is based on magnitude. To find magnitude in this chapter is easy. Just you have to remember equations. Important is direction. Important is direction. How to find direction? Clear? Okay, again, South direction means towards you. Current is flowing towards you. East direction means wrap your fingers in this direction. See, this thumb is going in upward direction. Clear? Then it is in upward direction. Find this answer. Use ui upon 2 pi r. Okay.